Hello friends, welcome back to another video on this channel. In today's video, I will show you my new creation. A completely custom made CNC type drawing machine without using any 3D printers or buying any kind of like pre-built machine hardware basically. So let me show you guys. Basically the concept is I have two stepper motors here and here which are connected to these two LN2003 boards. These are stepper motor controllers. They are connected up to this microcontroller here. Now hold on, don't click off the videos thinking that this is an Arduino Mega and you do not need one, because basically I have this SD card module. So because of that I'm using the Arduino Mega to log the data. But actually what happened was I did not have an Arduino Uno on hand, like my Arduino Uno was used up in another project and I just had a free Arduino Mega anyways, so I just decided to combine the SD card as well for logging. But realistically an Arduino Uno will work just fine, and I'll tell you more about the software as well as the hardware changes that you'll need to make for any microcontroller in just a bit. But anyways, aside from that, from here we have the Arduino Mega, the Arduino Mega, yeah, and just exclude this part here. We have both the these two motor controllers, stepper controllers. They are connected up to these two steppers, and basically the way I have it set up is I have these BO wheels. These are actually a normal, just standard red color BO wheels you can buy. And basically what I did was, if I take this off the mount here, basically these BO wheels, in one of them I literally just took a soldering iron tip and I just like basically just melted the my way out to create a kind of a pulley type system, as you can see here, this one. And another one I did a different method, and in this one I basically took an angle grinder and I put on a metal attachment and I basically just grinded through it to create a slot for the wire to go in. The way they are mounted is pretty simple. I basically took some two-phase epoxy. As you can see, I actually applied them here. Like I just took some two-phase epoxy and I just simply put them, like I just simply put the thing inside the bigger hole, bigger than, because they're bigger than the stepper motors can handle. And basically after that I basically just put it on, and after a while when it was pretty hard because the epoxy is not very sticky, I basically just took it off again, put a dab of super glue on and just tightly clamped them together. So now they're pretty steadily on there. For the mount itself, basically you want these spools themselves to be as low to the ground as possible. So because of that I have them on this, because I'm on this wooden platform. This is not my table. I have it elevated using some Lego legs, as you can see there. Basically what I did was I attached it onto a piece of Lego. I just took a Lego piece here, as you can see, and I attached it onto that using some super glue as well. And then that goes to this little L connector type thing here, and then that is connecting up to these stack of three of these little Lego like two, and then there's one for the rod type thing. I mean, this is obviously the whole purpose of this video is that we are not buying anything, so like you might have to engineer something yourself as well, but it seems like this works pretty well for me. Aside from that, for this end I have a bolt here, like just screwed onto the little platform. Ideally you would have a a pulley type thing, like on a bearing here. Same with here, same thing goes to there, same type of mount there as well as this one. This is just screwed into the board for using a black color little long screw. Now connected to here on this thing, main thing, the gondola. Basically the way the gondola is I have this platform here and I cut off this hole, this much of a hole for the servo's horn to push down. As you can see, this is what lifts the pen up and down to basically not like put the pen wherever we want to. And on this side what I did was I created a tiny little hole. If I flip it around, you can see I have a very small hole where the pen pokes through, and I put it onto this Lego bracket. I super glued this onto the little platform. This platform is, by the way, just some normal like hardboard you can find on like a cover of a diary or something like that. And I just cut a little, like I just carved away some of it using like a your normal cutter thing, and to fit this pen inside. And then I have these ropes coming up and mounted into these like U-shaped things, basically normal your knots. So these can swivel a little here and there. And in the back here, this is basically where I have the rubber band coming in. So yeah, basically the idea is simple. This rope, this is solid rope, doesn't move. It connects up to a rubber band. This rubber band is what stretches up when it goes up, and basically to give us that freedom of maneuvering as well as keeping a tension to pull it back, because obviously the steppers can't really push the thing backwards. It can only pull it forwards. So this rubber, I have the string coming up. I've connected it to one rubber band, then to another one, and then another one, and it goes back onto the string as well. So basically over here it's simple. I have the gondola mount again. I have a screw which is mounted absolutely perfectly flush. I simply just put a hole, and then I put a dab of super glue on, and I screwed it in, and then I just sanded the bottom a little to get it pretty flush. Onto the screw, this is just another piece of hardwood here, and this inside here, this is just a piece of Lego, like a I had this little yellow color Lego like thing with a which is supposed to be mounted onto two sides using your Lego clips, like the black color connector things you get. So this is one of those. I just put it on there. It basically spins freely onto the screw. So that's basically where the rubber band goes into. So let me quickly just fire this thing up. By the way, this is the hard. So you basically have a window here. I'll tell you more about this in just a second. So here I'll just click on draw vector. As you can see, I have a hello world loaded up, and as you can see here, the thing just starts moving and it will slowly start drawing. I showed you guys the time lapse of this in the beginning, so it's drawing the same thing. So while I'm explaining it to you, I'll let it draw itself, and I'll show you guys once it's done as well. Anyways, speaking of the wiring, actually to explain the wiring a little bit better, I'll rather switch over to the computer and show you guys the code instead, as the wiring is completely explained in the code as well. So let me just quickly switch over to the computer now. Okay, so I have now switched over to the computer, as you guys can see. So let me tell you guys what I need you to do. Now this one uses the standard iPad library. By iPad I mean the interactive programmable arts display thing. You can find the link to that on GitHub as well. I'll put that down below, as well as my modified code. So let me just quickly show it to you. First of all, what I need you to do is go over here into this polar graph folder. You need to go over here into polar graph, and here you'll find the processing source. You just click on this processing libraries and take these libraries and put it onto your processing libraries folder. Another thing is, you take this whole file and just putting into the processing source folder, like not into your where, like in the roaming here. If you go over here, you'll find your processing folder somewhere. There it is. Like you download processing, and now you just basically put the polar graph folder here. You just put it here, just paste it here, and in libraries you will have your processing library there. But basically the reason you cannot see the libraries I have installed as well is because that you'll understand in just a second. Basically, instead of using your other processing, we'll just install it to processing software. But after that, what you want to do is, you want to first of all, before that, you want to come here into the modified Arduino source. Same thing with your Arduino libraries. Here you'll put them into your Arduino folder, and then you'll click this one and upload this file. Now before that, I need to talk to you guys a little bit about the configuration of this as well. But before that, let me show you guys the processing system. Basically what you want to do is, you want to, after putting those folders into your raw folder, as well as putting the polar graph like the libraries into your raw folder, as like the processing folder, libraries folder, you want to come to here and click this one, and you'll find your processing.exe here. You'll open this up. Basically now I already have processing open up. So basically over here you'll come to file, and you'll go over here into sketchbook, and you'll see your processing polar graph controller here. Once you have done this, it should just disappear like you saw in mine. One more thing I'll do is, I'll link a video to another YouTuber who also explained this like basically code very well. So I'll link that video down as well. So if you want a little bit more detailed like proper tutorial type thing, you can watch that video as well. But other than that, basically after uploading that processing code and opening that, what you want to do is, you want to come over here, and now let me show you guys a little bit more about the Arduino situation. Now this is obviously, as I said, this is an off-the-shelf system, the iPad system. So now the way this works is not like, I did not create this code, and it is actually supposed to run on a lot of different types of computers and microcontrollers and stuff, which now this part actually the other YouTuber who did not explain very well either. So let me just quickly do it for you guys. Basically the main things you want to be doing is this here, it's mentioned here as well. Now you can use something like this UNL 2003s like I am using, and a separate stepper motor, or if you want you can use your something like the Arduino Adafruit motor shield, which is basically your pre-built stepper drive motor shields, as well as your like your CNC shields, and using your the A something something with the stepper motor controller which go along with those CNC shields basically. So if you want to use those, I'll tell you guys what changes you need to do, as well as what you need to change if you have a Arduino Mega Uno. So first of all, if you have, let's say you are using the same system and you have this ULN2003, all you need to change is over here. As you can see, I have defined Arduino Mega as I'm using the Mega. You will want to undash these, like you will uncomment this line and comment this line, and then you'll you'll comment both of these lines as well, the SVI and the SD. This is just for your library if you have an Arduino Mega. So you will want to comment these lines and uncomment this one and comment this one. Basically what I'm trying to say is, wherever you see these SPI and SD cards, this you will comment, and your Mega will be uncommented and the Uno will be uncommented basically. So after that you want to come over here, and I'm still assuming you are still using our standard Arduino Mega. So basically all you have to do is put your servo motor, which is the pen servo thinger, you want to put that onto your A3 pin. As you can see here, it is in A3. You will put it to your analog 3 pin, the servo motor. Now don't worry about the angle which it is for the pen up pen down, that will set in the processing software only. I'll show you guys that as well. Important thing is here, if you are using your ULN 2003 like I am, you want to make sure you want to use these exact pin outs. It's mentioned here in the code. You will put your motor B, which is basically your right hand motor, as in my case, as you saw, and we'll put them exactly onto these codes and these ones here for the motor A. So after doing that, just check if it's reversed, like you can just simply reverse the motors. These are just 4 pin motors, so like if you put it one way, it will go one way, and then the other in the opposite way. So just if it's going the other way, like if it's going opposite to what you expect it to go in, just flip the connections and it will work. You don't want to change any of these as well. Now that's basically it. If you are using the same system, you don't have to change absolutely anything. You just have to connect them up to those pinouts I just shown. This is, by the way, in the configuration.ini folder. You will see them up here, and A3 for the servo. Now if you are using your Arduino Uno, the only things you have to change is just as I mentioned, comment these, uncomment this one, and comment this one, and that's basically it as well for you. Now if you are using your Adafruit motor shield thing, what I would recommend is basically what you need to do is you'll have to come over here and you'll uncomment all of these 4, and then you will comment this. So you'll put the comments onto this one, which is your ULN2003. Do not have to change any of these. These are all going to be figured out by itself. The only thing, you will again come back to the configuration.ini file, and over here same thing. If you will basically comment these two. You will basically over here you will go ahead and uncomment your Adafruit one right over here. Yeah, you'll see this one should be commented, so you'll just uncomment these if there is any comments here, because my code I'm not using them, so there is none here, and these should be uncommented. This one should be uncommented. If it isn't, just comment them as well and put them up, and make sure that none of the lines here is commented. If you are using your motor shield V2 or your V1, that you'll just have to check which one it is. You'll find them either on written, or if you are using like one of those compatible versions, then you'll see which version they are copying. So that one you'll see, and you'll define that particular one here, because both use different pinouts. So you'll need to comment exactly the one which you want to see. So here, for example, if you are using V1, you'll just uncomment these two. If you are using V2, you'll uncomment all 4 of these lines. So that's basically it for the Arduino code as well. So I'll close this here now, and I'll show you guys about this guy. So as you can see, by the way, this is done. This is the live preview. Once you will open this, what you will want to do is click over here, load config, this button here on the corner. You will go over here, and in the same folder, iPad master folder, in the live folder, you'll see this one properties.txt. You will open this one, and after that you will come over here into setup. You will click this upload machine spec button. You will go ahead and click this send speed button. and then over here you'll click this upload lift range button here. Now, oh, one thing I forgot to mention one thing. The dimensions are necessary unless you want to figure them out here. I'll show you guys that in just a second as well. But the dimensions for my system are basically you want to have the poles to the like the length of the thing, basically from the screw till one of the stepper motors to be 34.5, around 35 centimeters roughly, and the distance between the two stepper motors should be around 30 centimeters roughly. That is the size you want of here. Now if you want to change something, here is your machine width, basically the width of the machine. So this corner would be a stepper 1, stepper 2, and then these 4 corners. This is your machine width. You will have to mention that because that comes into the calculations, as well as your page width. So basically what amount of usable area you actually have, so that one you will mention over here, as well as this thing here, pen up pen down position, as I was saying. So you just want to experiment with this a little up and down, and you will click every time you'll do that. You'll click this upload lift range, you'll upload this machine spec, and you want to click the save here. So it will save onto the file, your basically your properties file, because every time you close the window and reopen it, you will have to re-upload the file. After that you will come over here, and as you can see here, it's running now. So you will see it like this, which is paused. You want to click this to run the menu, and every single command you just did, including the sending the specs and everything, those will be run and sent to your computer. After doing that, over here, now for testing whether your pen is working correctly or not, you have these 2 buttons, so up and down. Once you have done those and you are happy with them, you will basically roughly center it, or wherever you roughly want your print to start from. You will go ahead and place your gondola thing physically onto that point. You will click this button here, set pen position, and you'll, for example, I want my hello world, this one text, I'll show you guys that as well. You will click it wherever you want. So let's say you want to start from here, you'll click it here, and basically you'll see that this, if I do this, as you can see, this purple dot will shift here. This is where it thinks its current position is relative to your machine, the position of the gondola. So based on this, it will do all your calculations. Now if you want to physically move it using your mouse, you'll click this button here, move pen position. You'll click it, and now if you place your dot wherever, your machine will actually start moving there. In the physical machine will start moving there. And now next thing is over here, down here, if you go over here, you will find it something like this, load vector. You'll see, click this one, and now in the same Arduino processing folder, I have uploaded a few sample designs. Basically I have a car here. This one is just the outline of a Bugatti Chiron. This is the Bugatti logo, and this is the Hello World logo. The other basically I've set them up basically as in increasing level of complications. So if I go over here and show you that, basically the Hello World, this pretty simple, just writes Hello World. This is a bit more complicated. This Bugatti logo, it just does the standard Bugatti logo, as you can see. And then this is even more complicated. This is a proper it tries and outlines this whole car into the paper. Now I would not recommend you do that before completely setting everything up properly, and until you're happy with it. So that's basically it. Now once you have uploaded your vector, as you can see, I have uploaded my vector here. Once you have done that, you want to come over here, and you want to move your, if you need to move your vector, you'll click this button, the move vector button, and as you can see, you can now place your vector wherever. And it okay, before that you want to click the select area button. This is the printable area. Like let's say you have a vector like a SVG image, and you have, like I showed you the Bugatti Chiron image, for example, down there the logo of the website where I downloaded it from is also there. So if you don't want that to be visible, you can basically select the actual area where you want it to be, and then you'll click this button here, set frame to area. So then you will see that the vector will actually pop up. Now if I clear the vector and I go ahead and load the Hello World vector again, as you can see, this will pop up. And now if I go ahead and click set frame to area, as you can see, I don't know what this green image is. I was actually trying to print something. I think that is just there from that time. It might be an image or something, I'm not sure. This won't come up in your case. This is just here for some reason. I am not very sure why. In fact, if something like this does happen, just simply select just the area you need, and it will just print that area. As you can see, it just disappeared. I think that is from a previous print. I was test printing a car on my thing. That's right, that was there. Maybe it's just still loaded in the system for some reason. Anyways, once you have done this, you will see down here your move vector as I showed, and this resize vector. So basically, in this system, if you want to these values, you will basically click it and you'll move your mouse up or down to increase or decrease the values. It isn't scroll, it isn't arrow keys, nothing. It's simply moving it. So that's it. And now once you have done that, you are happy with where you are with respect to the page, you are happy with where the vector is, you are happy with all of that, you have set your pen position correctly, and you have physically set everything up, you have secured your page down. You'll come finally down here and click this button, draw vectors. Now I'll recommend you have this closed, and now you'll click your draw vectors, and as you can see, the whole thing will pop up here what it commands is, and it will show you live here. As you saw previously, it was showing it live, and it what it thinks it's doing. So the red line is what it will follow, so it will do that, and once it's done, it will basically just stop and pull it up, and that's basically it. Now as I said, my thing is done. So let me just quickly show you guys that as well. As I showed you in the previous one, it's the same thing that's printed, but let me go ahead and show it again as well. As you can see, my thing has stopped printed. I think it stopped printed while I was explaining the code. So as you can see, it has already lifted the platform. So now when I pull it out, it won't cause a ink spill. And as you can see here, it has printed my words hello world here. Now obviously we are not using 3D printing, so the it's not very precision, like the tolerances are very not good. Also we are not using any real bearings, so like it can't swivel freely on the back or over here or over there. These mounts are pretty bad. These are wiggly as well. As you can see, it wiggles pretty badly. These pulleys themselves are not good at all, like they're pretty rough, and the wires keep getting caught on them, this one as well. So because of these reasons, obviously you have to keep our expectations low. This will like if you did the thing that everyone else does properly, then it will be a little bit better. Anyways, we are trying to use strings instead of using, like if you see in professional ones, they have these aluminum beams going across, and those are connected to steppers, and the motor moves very smoothly on those with perfect lines. We are using strings and a cross system here. So because of that, obviously straight lines, like especially up down lines, go pretty not straight actually. So you have to keep that in mind, keep your expectations low. But as you can see, it's not bad at all. Like you can clearly make out the words what it's trying to say, and you can even see the resemblance here, hello world, and on the screen, on the screen as well, you can see the hello world it's trying to write, and you can see the hello world it printed here. So yeah, that's basically it for this video. I hope you guys enjoyed. If you did, please be sure to leave a like, subscribe to the channel, and yeah, I'll see you guys next time.